Hi, I'm Paweł Spychalski, and ever since the Betaflight introduced the RPM filter, some pilots say that you cannot really fly without the RPM filters because you are changing everything. This is of course not true, although however in some of the cases, yes, the RPM filters are a great help, and in some of the situations they really improve a filtering of the noisy gyro a lot. INAV 2.4 is bringing you the RPM filters to the INAV world. Those are not Betaflight RPM filters. This is the implementation of the same idea in a slightly different way with one extra, let's say, a limitation. INAV doesn't have yet a bidirectional DSHOT support. That means that the RPM filters will work only and only with the BL-Heli32 connected via a separate serial port. That means that the BL-Heli-S or JESC or something like that with the support of the bidirectional DSHOT will not bring the rotation speed information of the motors to the flight controllers. You have to have the BL-Heli32 connected to one of the serial ports. Besides that, it works just like that. Some say that it's a huge problem. Maybe not. Depends. It's not that you cannot fly without the RPM filters. No. I will want to make a separate video that I will, let's say, try to bust some of the myths about the filtering, but not yet, not now. Today, if you do have BL-Heli32 and you do have the ESC telemetry connected, this is a tutorial how to set up, configure and use the INAV 2.4 RPM filters. Setting up the RPM filter in INAV is pretty straightforward process, but like I said in the opening part of this video, you do have to have the BL-Heli32 telemetry wire. There is no bidirectional DSHOT support yet, so you are really limited only to the BL-Heli32. Maybe in the future releases after 2.4 of INAV this will change, but for the INAV 2.4 you do need a BL-Heli32 with separate serial port connected between ESCs and the flight controller. I have a separate video about configuring this, so the link is somewhere in the description, so just take a look and see detailed instruction how to enable everything. We, however, today gonna do a fast setup without going into the details. So first of all, after seeing this dialog, please choose what you are flying. This really helps a lot, and if you are using and want to use the RPM filter on the 3 to 7 inch propellers, use the option. This sets a lot of settings inside of the INAV and really makes the INAV fly much better. After doing this, the next step is always to set up a mixer. One of the most important things you have to set. Please remember that without setting a mixer you will not get any telemetry ever, because the INAV has to be aware of how many motors you have. After doing this, the next step is of course to go to the outputs and to enable DSHOT. Any DSHOT is fine, it doesn't matter which one you choose, but it does have to be a DSHOT, because only a DSHOT currently sends the request for the ESC to send the telemetry back. Also, while being right here, you might verify the number of poles on your motor. Majority of the motors for above 5 inch propellers are 14 pole motors. Something smaller like for 2-3 incher cine whoop, tiny whoop, whatever else might have a lower number of poles, so please verify this. How? By checking the number of magnets on the motor, and this value, number of poles, is just the number of magnets, so just count it. Let's save and let's reboot, and now the final step towards enabling the ESC telemetry. is to go to the port stub and enabling this on the serial port on which you have the TX paths from your ESCs connected to the flight controller. In my case, it will be the serial port 5. There is nothing else besides the ESC output telemetry. Let's save and reboot. Right now, when you arm, when the ESCs are powered and everything is wired correctly, the INAV will be getting... no, there is one more caveat. I forgot to enable motor and servo output. Without this, nothing would work. But okay, now we enable the servo output. And now when you will arm, the INAV should get the information about the RPM of each of the motors. You can check this by setting a debug mode for the RPM and setting this here in the debug tab if you are getting correct data. But honestly, the kind of simpler way to do it is go to the OSD and simply put the RPM element somewhere on the screen. Save it, arm, add some throttle, check in the OSD in the FPV feed if the value of the RPM is more or less corresponding with something that you might expect from your motors. Okay, let's not go that road, this is too wide of the topic. Now after this part is set up, we can go to the CLI and start setting the RPM filter up. First, run command tasks. And when the RPM filter will be running, there will be a new task called the RPM, of course. Right now we have only telemetry, so nothing is enabled. Type get RPM. This will get you all the settings connected with the RPM filter. As you can see, there is a main switch for the gyro filter and the main switch for the D-term filter. First of all, forget that the D-term filter is even there. It will be removed in the next versions of INAV, so just skip it. The main configuration you have to set is RPM gyro filter enabled. So just type set RPM gyro filter enabled equals on. And now we can check if we have to change anything else. First of all, RPM gyro harmonics. This is the number of series of the filters in line. Some people suggest setting this to 3, some to 2. I honestly suggest that if without taking a look at the characteristic of the noise, if there are visible harmonic frequencies of the main motor frequencies, you should not touch the setting at all, and RPM gyro harmonics 1 just gives enough attenuation for everything. If, however, you have really like the super noisy frame with super rattling motors and super unbalanced propeller, then after checking if there is something above the main frequency of the motors, you might want to increase it. But honestly, don't bother without taking a deep dive into the characteristic of the noise. And the second is the RPM gyro min HZ. This is the lowest frequency that RPM filter can use while flying. What are the values over here? This more or less depends on the diameter of the propellers you are using. For the 5-inch props, and which is default for the Betaflight, they suggest using 150 Hz, and this is fine. However, even setting this as low as the 100 Hz on the 5-inch mini quad is fully fine. If, however, you are using a 7-inch propellers, you might want to set it even lower. My 7-inch rigs with the RPM filters are set to RPM gyro min HZ 70, because sometimes when you are just hovering, the frequency of the motors is really low. Nevertheless, 100% is a nice default, and I suggest to begin with the 100 and checking if everything is fine. If, however, you observe that on the low throttle something is rattling, something is not really working like you expect, you might set the value slightly lower. And like I said, even 70 Hz on the 7 inches is fine. Although if you are using 5-inch propellers, don't change this value, it's fine. For the lower size of the propellers, 4, 3 and even 2 inches, the default 100 and 150, you might want to set it at 150 on the 3 inches, is fine. There is no need to set it at all. And now let's type save and let's see what's happening. Okay. Now, after reboot, let's go to the CLI again and type tasks. Right now, over here, as the task 24, you can see that there is a separate task that every 500 times every seconds checks the RPM of every motor and sets all the notch filters to the desired value, desired frequencies, to really attenuate those frequencies. And that's all. You do not have to do anything else. What you, for the beginning phase, might want to check is to get debug. And if you want to check if all the motors are set to the frequencies, there is a debug mode called RPM filter. After setting the RPM filter debug mode, the notch frequencies, the motor frequencies of the first 4 motors on your quad, or something bigger, because only first 4 will be locked in the black box lock. You will be able to see the frequency. Now, there is one more thing that we might want to change when the RPM filter is running and is in place. It's the configuration of the dynamic filters. So let's go to the PID tuning, filters and gyrodynamic notch filters. When the RPM filters is in place, you might want to set dynamic notch width to 0. This makes that instead of 2 banks of filter, there is only 1 bank on filter. Of course, configure the mean frequency to something. I do not suggest going below 100 Hertz. Save and go to the CLI again. Now, when you will type get din underscore, there is something called din notch Q. This is the Q factor and tells us how rapid the attenuation step of the notch filter is. We've enabled the dynamic, the RPM filters on the motors. You might want to raise the din notch Q slightly to around, I'd say 200 is a good starting value, but this value also you might want to fine-tune it to really make sure that everything is fine. But this step is really optional, it's not required. Usually setting the din notch width % to 0 is really fully enough and you do not have to change anything else. And that's all. The only last thing you might want to verify during the flying is to check if the OSD element with the RPM that we configured previously is not resetting somewhere in the flight. If you have this element resetting to some kind of the default value of 42,000 or something like that, that might be the indication that there is a lot of electrical noise on the telemetry sent from the ESC and the flight controller is unable to receive the correct frequency, the correct telemetry. But this is not really happening very often, but it's really something worth to observe, especially during the first few flights. If you are getting a telemetry in the whole full range of the throttle, if extensive noise from the motors or propeller is not causing any kind of the troubles. But besides that, that's all. Like I said, relatively simple. Although there is no graphical user interface yet, it's not that hard to enable and use the INAV RPM filters. That's all for today. Until the next one. Bye bye.